We found that only simple integrations problems can be solved with the knowledge that we have discussed before. So we need to use a techniques that call substitutions techniques or integrations by part to find the solutions for more complicated integrations problem. The integrations by substitutions is actually the reverse of the chains rule. In the chapter of differentiations, the chains rule is to use to determine the derivative for the composite functions h of x equal to f of g of x. So it means that there is a functions of g of x inside the functions of f. Then the derivative for the h of x, we will get this in the chains rule. Now we can reverse the differentiations to get. So let's reverse the differentiations. Then we will get this thing back. Plus c here. Okay, if we replace u equal to gx, so this is where the substitutions come in, then we can rewrite this integral as f prime u du dx times dx equal to f of u plus c. So in short, if the given integral is half of the form of this, then the step for solving such an integrals problem can be summarized as follows. First, we're going to choose the substitutions u equal to gx. And then we find the derivative of u, means that we differentiate gx. And then we rewrite u equal to g prime x dx. Then rewrite the integral in terms of u and solve the integral in terms of u. And finally, replace u equal to gx into the result so that we get back a function in terms of x. Now, let's look at this example. The integrand is 4x e to the x squared. We have a problem to do the integrations directly due to this term. So, by using the substitutions techniques, what we can do is we just substitute u equal to x squared. This term. Then we differentiate. So du dx, differentiate x squared give us 2x. Then we derive dx equal to du. Okay, I bring this one to the left and bring this one to the right. I swap them. So dx is du over 2x. Now I can rewrite this term as 4x e to the u because x squared is u and dx is this term, so du over 2x. And this can be cancelled. I should say can be simplified as 2. So now our problem is 2 e to the u du. This is our integrations problem. And this is easy to be integrated. To integrate e to the u will give us e to the u back plus c. And the final step, we just substitute u as x squared. So this is the result for this integrations problem. Next example, to integrate this problem, we couldn't solve this part. So what we do is we just do a substitutions. we substitute 2x minus 5 equal to u. Then we find du dx. Differentiate 2x minus 5 gives us 2. And dx is equal to du over 2. Okay, I swap these two parts. So now I can rewrite this as x, 2x minus 5, that is u, square root, so that is power of half. And then dx is du over 2. Okay, up to here the problem haven't solved because we still have an x term here. But we wish to change the whole terms to u. So now what we can do is we come back to this term, get what is the x. Okay, I shift the negative 5 to the left hand side and then I divide by 2 so I can get the x. So it means that x is u plus 5 divided by 2. Then this one become u plus 5 divided by 2 times if u half times if du over 2. So I bring the 1 over 2 and 1 over 2 here out. I have 1 over 4. And u times with u half, I have u to the power of 3 over 2 plus 5 u to the power of half du. Then just continues to integrate this. Integrate u to the power of 3 over 2, I have u to the 5 over 2 divide 5 over 2. And to integrate u to the half, I have u to the 3 over 2 over 3 over 2 plus c. So finally what we can do is just to simplify this, and hence we're going to get this 1 over 4 times if 2 over 5, then that's going to give us 1 over 10. And then substitute u with this 2x minus 5 plus and 1 over 4 times with 2 over 3 because it's divided by 3 over 2. So that gives us 5 over 6. Substitute u with 2x minus 5. And finally plus c. So this is the answer for this problem. Third example, we're going to solve an definite integral with the limit. So what we can do here, problems come from this ln x. So we will substitute u equal to ln x. Then differentiate ln x will give us 1 over x. So dx is equal to, I move the x to the left hand side and move the dx here. So dx is equal to x times du. So we can rewrite this problem as 2u times if x, 2u divide by x times if dx, which is x times du. Since this is the definite integral, we need to apply the substitutions to the integrations limit also. So what we can do is we just say when x equal to 1, then u equal to ln x. So u equal to ln 1, which is equal to 0. And when x equal to 2, u equal to ln 2, which is equal to 0.693 for upper limit. So in this case, the lower limit is 0, upper limit is 0.693. Then if we integrate this, we're going to get 2u squared over 2. from 0 to 0.693. And I simplify this. Now we write the solutions. No, I can just substitute already. So 0.693 square minus 0 square. I substitute u with 0.693 and 0. Then that gives us 0.693 square or 0.48. Alternatively, the integrate limits can be ignored temporarily while the integrals is in terms of u. Means that I can skip this step. So what I do is, at this step, I solve the problem without the limit. So it's 2u over x times x du. I didn't put any limits here. So then I solve this one. I'm going to get 2u squared over 2 without the limit. Okay, then I get u squared. When I'm in u squared, then I sub it back to the ln x. So become ln x squared. When I'm in x, then I use back the limit for x. 1 to 2. So it's going to equal to ln 2 square minus ln 1 square. So I get back the answer. Here,